So continuing our tour of this continuous wave NMR, we sort of took a global look at all the equipment in the last video here. In particular, we looked at the electromagnet, the solenoidal coils that allow us to modulate the static magnetic field, this little brass sandwich in here that contains a sample that we drop in, which is a coil where the RF is delivered. So there's a lot going on here. There's a wiggler magnetic field, a static magnetic field, and RF being delivered. And then, of course, we have over here the sort of the control box here, which has the NMR frequency in megahertz, has an amplitude and frequency knob, and of course we have the modulation control over here for that wiggler magnetic field, so we can be sure we'll find that resonance. So as promised here, we want to look at the oscilloscope a little bit now and see what sort of we get on that. So what we get on the oscilloscope is I have sort of two channels going here. Let me turn channel 1 off just for a moment. Channel 2 then, that comes in on the oscilloscope, this wire right here, is coming directly from this line here, which says delta B signal. In other words, the modulated magnetic field is coming out. I'm just routing that into channel 2 of the oscilloscope. So you can see that indeed it is a sine wave here. The current is ramped up in those coils and down in those coils and up in those coils. And down definitely means negative, so that means that the magnetic field that ends up getting supplied in these two wiggler coils here definitely changes direction. So it goes this way, and then it goes that way, and then it goes this way, then it goes that way, and that's the nature of the game. One sort of irritating part about this signal is it is not quite symmetrical around 0, and you can just sort of look at it here. If I put 0 right at the center of the oscilloscope, you see it's definitely higher for a smaller amount of time than it's lower there, even if I turn these cursors off. And that sort of causes some problems in how useful this signal will be, so you'll see that when I use cursors to identify the resonances during the data taking videos there. But in either case, the modulation is going out. I can definitely change its amplitude. See, I can make it lower or higher, doesn't matter too much. And I can change the phase of it too. See the phase shifting around a bit, not so apparent on the oscilloscope there. Okay, so that's sort of what that is. Then of course the NMR signal comes out on channel 1, and so channel 1 here, the oscilloscope, this wire right here, is connected to the output labeled NMR signal right here on the control box. And what comes in directly from that coil that we apply the RF onto that holds the sample is this probe right here. So this line is definitely an input from the coil. This one comes out from the device to the oscilloscope. And so you can see that this is definitely the sensitive signal here, bounces around quite a bit, but the name of the game then for working on the NMR then is you sort of look at the oscilloscope with your hand on this frequency knob and start scanning the frequency until you see an NMR signal sort of pop up on the yellow trace right there. It's very undeniable. The trace will just be very, very obviously different. It won't just be a flat line. I'm sort of turning it now with the hopes I'll find something quickly, but it doesn't look like I'm going to. But we'll see that in other videos. But you can see it's very sensitive. Just sort of changing the frequency makes it bounce around. If I sort of wiggle any of these things, like all I'm doing is sort of touching this wire here, see it sort of goes all over the place. So it is a sensitive experiment, and the data videos are kind of difficult to take. But in either case, that's sort of the plan for continuous wave NMR. A lot going on over here: static magnetic field, wiggler field, RF applied to a coil, pickup in the coil over here, frequency adjust over here, oscilloscope is our trusty guide, and of course the high current power supply for getting the electromagnet to supply a static magnetic field. So that in a nutshell is sort of the entire setup for so-called continuous wave NMR. The continuous wave comes from the fact that the magnetic field over here is always on, the wiggler field is always wiggling, and that's how we go about looking for our signals, our NMR proton flip signals.